Hello all. So welcome to day 17 of our exciting AI journey. I myself Akshay Goyal. So today we will cover convolutional neural networks and how they are used for image processing. So I hope you have covered all the videos till now in our 30-day AI content challenge. And if you have any doubts, please do put in comments. And also you can mail us at aicodegan@gmail.com. So and before that, what you can subscribe to our channel AI Codegan, hit the like button and click the bell icon, so that you don't lose any day content of our AI content challenge. So let's start. Hello, let us talk about convolutional neural networks. So it is a deep learning model for image processing. It automatically extracts features from images. I think we have talked about other neural networks. So we need to extract different parts of the images in pieces. And convolutional networks is used in image recognition, object detection, and medical imaging because of the high accuracy. And why it is used for image processing? Traditional networks struggle with high dimensional data, but while CNN sufficiently process images by preserving spectral relationships. So suppose there is a home, so it will, process its image by preserving its door, its windows, and its room. So it will distribute the three images, three spectral features of the home. Then it will process the image. Whereas if we use some other neural networks, then it will involve more complex operations, including different figures for the gate itself. The door itself will have different parts of the door as well. So it will process a lot many hidden layers. So this also reduces computational complexity while improving accuracy. Now let us understand the structure. So when we talk about structure, so it has input layer, which is the first layer which takes images input. It has convolution layer, the second layer which extracts features using convolution filters. Third layer is activation function layer, or you can say review, which is most commonly used, which introduces nonlinearity and removes the negative part. And fourth one is pooling layer, max pooling, which reduces map size. So it will reduce 4x4 matrix into 2x2 matrix. And fully connected layer is the fifth one, which connects neurons for prediction. So this is the part where we have some hidden layers present to process into a fully connected layer. And now we have the final output layer, which classifies the image. Let us understand using an example. We have an input image of a zebra. Then we have feature maps. So first process is feature extraction. So what we are going to do, we will apply convolution here, filters plus value activation. So what this will do, this will give us a matrix, reduce matrix, and this will go to max pooling, and that will flatten the layer to reduce size of matrix. It is also called as downsampling. Now we will send it to fully connected layer. So how it will happen? This layer will go through different hidden layers for classification, and at the last we'll decide the probability of each feature using softmax activation function. So we can see here, this is a trained model. We could accurately get 0.07 for zebra, which is the accurate prediction. So we might get inaccurate like we have seen for other neural networks. We need to train the model highly effectively so that we get correct probability results at the end. Now, let us understand the working of CNN. So as we already covered, so we have convolution, which detects edges, textures, and patterns. We have value activation, which knows negative values. We have pooling, downsampling, reduce feature size while keeping it is fully connected layers, which gives the final prediction. And this final prediction will go into the softmax or sigmoid activation function to give the final output. So let us go next to details of each step. Now let us talk about step 1, convolution operation feature, which is also called as feature extraction. So here we are going to use the convolution multiplication. So O of I of j will be summation of I of I minus a comma j minus b multiplication product of k of a comma b. So here we can see this is a given matrix of this is a 4 comma 4 matrix. After using kernel of 2 by 2 matrix, this is called convolution kernel or a filter. So this feature, we get the feature map of 3 cross 3 matrix. Let's see some example. So here we can see we have reduced 4 into 2 cross 2. So we can see we have reduced our image of 8, digit 8 into a small image. So this becomes more easier for processing. Similarly, when we talk about this image of a fruits, like watermelon is there, banana is there, grapes are there, and apple is there. We can see after convolution kernel, after the feature extraction, how it looks like. So, and similarly here we have this army man whose image is filtered using kernel, and now we get the output after using max pooling. We get an output like this. Let us go to the next step, activation functions. When we talk about activation function, we mostly use rectifier linear unit, that is redu max of 0 of x. So you can see from this matrix example how after convolution layer is processed, this output of convolution is processed through ReLU, it will rectify the negative output. So now we don't have any negative output, so we can see from this image, so when input images went through, it was the rectifier, it will rectify the negative output. So now next will be pooling operation. So this is also called as downsampling. So how it is done? Suppose we have 4x4 matrix, it is downsampled to 2x2 matrix for easier operations. I'll explain the mathematical operation full through a video which I'll put in the description. So for understanding, let us see how we are going to do. Suppose this is 4x4 matrix, so we are going to take 4 2x2 matrix. We are going to take maximum of 1, 3, 5 and 6, so which is 6. Similarly, we are going to take maximum of next 2x2 matrix is 2, 4, 1, 0. So this will be 4, and similarly 9 here and similarly 8 here. So we could get a reduced sampling of 6, 4, 9 and 8. Now we have fourth step as fully connected layer, which is similar to the other neural networks. Here we had weights and biases to process the feature maps. This will flatten the feature map. Now last is softmax function. So we have already studied this in our last video, where we have the equation of the function is e of exponential divided by summation of e of exponential over the probabilities, or you can say for the points. So here we can see it has curved the raw sample is equal to this need probability between 0 to 1. This is the output of the softmax function. Now let us talk about real life applications. So we have image classification, which we already discussed, identify objects and images. We have face recognition, which is highly used in security and social media. Nowadays it is used in different parts of even security features. Even in airports we are using this. Medical imaging for detecting diseases and X-rays and MRIs. So we have huge amount of application uses in medical imaging as well. And the last we'll discuss is about self-driving cars. So I hope you all have studied about it. You might have heard about self-driving cars. So you might be amazed to know how we recognize patterns, traffic signals, obstacles. So it's all convolutional neural network which will take part in it. So is now we have already completed convolutional neural network. I'll cover these all the mathematical steps in a separate video to for the more understanding. So you can find the link in the description. Before that, if you have any doubts, just put in comments. Thank you. Hello. So today we have covered convolutional neural networks and how it is used in image processing. I hope you have understood the concepts. If you have any doubts, you can comment, and also you can email us on aicodegyan@gmail.com. And please do watch other videos in the playlist. We'll mention the link in the description. So if you have missed anything, please do watch the videos. If you have any doubts, just put in comments. And next we'll be covering what is RNN, what is recurrent neural network, and also LSTM we are going to cover. Now, if you haven't subscribed to the channel, please do subscribe to the channel AI Code Gyan and hit the like button. Thank you. So keep learning AI. Let's learn AI together. Bye bye.